with these. We've kind of already done a lot of things like this, but we're going to take it one step further today. So thinking of two numbers that multiply together to 24, what could they be? 4 times 6, what else? 1 times 24, what else? And last one? There it is, 8. 8 and 3. Good. What about 15? Perfect. What about two numbers that multiply to 0? 0 times anything, right, is going to give us 0. Yeah? So here in 5a, what does the value of the heart have to be? 0, right? Same thing if I wrote this like, instead of 7 times heart, what if I wrote it like this? What does x have to be? 0, right? Something times something equals 0. One of those things has to be 0. Yeah? So heart equals 0. What values of a would make this equation equal 0? 0, right? A has to be 0. What values of heart would make this one 0? 0 would work, but what else would work? 1, 2, 3, 4, anything would work in here, right? Because 0 times anything always equals 0. What about in part D? What does A have to be for this to equal 0? 0? Let's try it. So if I have, 100 times 5 minus 0, does that equal 100? Or does that equal 0? No, because what's 5 minus 0? 5. So this would be like 100 times 5, right? So what does A have to be? Yeah, why does it have to be 5? 5 minus 5 is 0. That's it, right? So this is saying like 100 times 5 minus A equals 0. And I know that if something times something equals 0, then one of those things has to be 0. 100 is obviously not 0, so that means 5 minus A has to equal 0. If 5 minus A equals 0, then A has to be 5. So let's use that same logic to figure out part E. What does x need to be in order for x minus 9 times 23 to equal 0? Yeah, 9. If I put 9 in place of x, I'm going to end up with 9 minus 9 here, which would just give me 0. And 0 times 23 gives me 0, so x has to equal 9. What about in part F? What does x need to be? 4 is good. And what else? Could be 4, could be not 2, but you're close. -2. -2, because if I put 4 in place of x here, I'm going to end up with 4 minus 4 to give me 0. If I plugged in -2, and I plugged it in right here, that would also give me 0. So when I have something, is this, what kind of form do we call this when I've got like two binomials multiplied by each other? Factored form, good. So when I have something in factored form like this, I just need either one of my factors to be 0. So I've got x minus 4 could equal 0, or x plus 2 equals 0. Okay? And again, right, some people can just see that. I see x minus 4 equals 0. That means x has to be 4. We can also solve this, right? If I add 4 to both sides, I also find out that x is 4 that way. -2, x equals -2. Okay? So then same logic, same kind of thing that we're doing here. Number 6a, what values of x would make this equal 0? What would I have to plug in for x for this to equal 0? X could equal -5 or -3. Perfect, right? So again, I took this little chunk right here, this one factor, x plus 5, and I set that equal to 0. If I subtract 5, then x equals -5. But also, I have the possibility of making this factor equal 0. So x plus 3 equals 0. Solve for x, and x would equal -3. So for these problems, we're solving for x. Usually that means we just end up with like x equals 4 or something. But now we have two values that x could be. So you're always going to have two answers, x equals -5 and x equals -3. Okay. In part B, it asks about the x-intercepts. We've talked about x-intercepts before when we were looking at linear equations. And remember, the x-intercept is where the graph crosses the x-axis. X-axis. So what is the y-coordinate of this point? What's the y-coordinate of this point going to be? 0, exactly, right? This point right here, the y-coordinate. The x-coordinate could have been 3, for sure, but the y-coordinate is 0 because it's always on the x-axis. So remember, our x-intercept is just the value of x when y equals 0, okay? So remember that. X-intercept means the value of x when y is 0. And then we have something else that you might have seen before, but we haven't explicitly talked about it yet. I'm going to teach you it next Wednesday. This right here, f, you read this as f of x. F of x. This is what we call function notation. And I'm not going to get into the details of it today. I'll teach you it next Wednesday. But for right now, when you see something like this, f of x, you can just replace it with y. So instead of f of x equals x plus 5 times x plus 3, we'll just put y equals x plus 5 times x plus 3. Okay? And okay, so let's back up. So we're trying to find the x-intercepts of y equals x plus 5 times x plus 3.
Why is that f times x?
This is just a different notation. It's a different way of writing about functions. And I don't want to like bore you with the details today. I'm going to wait until next Wednesday to show it to you. But essentially what it's saying is this is the function f in terms of x. F of x. So you can have f of x, you can have g of x, h of x, w of x, but it's just naming different functions. And that can be helpful when I have, like, let's say I had two functions I was looking at. I want to be able to like distinguish between them. This one is f and this one is g. Instead of just having them both be y equals, and then I don't know which one I'm talking about.
Yeah.
Okay, so don't worry too much about that right now. Just know when you see f of x or anything like it, you could just replace it with y, and it means the same exact thing. Okay? But again, we'll talk more about it next week. Okay, so I'm trying to find the x-intercepts of this equation. So remember, the x-intercept is the value of x when y is 0. So let's rewrite this equation with 0 in place of y. So if I rewrite that with 0 in place of y, I get this. And look at that. I end up with the exact same equation I had in number 6. right? X plus 5 times x plus 3 equals 0. 0 equals x plus 5 times x plus 3. It's the same exact equation. And what values of x would make this equation equal 0? What? -5 and -3. So that tells me where my x-intercepts are going to be. And we'll get more into that later on. But for right now, it's really just as simple as looking at your factored form, and figuring out how am I going to make both of those factors equal to 0. So in this one, I'd have to plug in -5 to make this part 0. And in the other one, I'd have to plug in -3 to make that 0. That's like all we got to worry about for right now. Okay, what about number 7? Number 7, what kind of form is that in? Standard form. What we need to do first, if we have something in standard form, we need to make it factored form first. That's why we've been factoring. So let's factor number 7 together. What do I need to look at to put this into factored form? Is there a number out in front of the x squared?
No.
No. So I don't need to do my whole like fancy t-chart thing. I just need to look at this last number. What are my factors of 15? What are my factors of 15? 3 times 5 and 1 times 15, right? Which one of those pairs is going to get me to 8? 3 and 5. How do I use 3 and 5 to get to 8?
3 plus 5.
+3, +5, right? And remember, we're just trying to come up with our 2 binomials that will multiply together to get us back to this. So what do I definitely know my first and first terms are going to be? X and X. And then remember this +3 and +5 tell me what to put here and here. So now I have x plus 3 times x plus 5 equals 0. So what values of x is going to make this equal to 0? Say that again. Exactly, -3 and -5. So there's several different ways of writing your answer. You can write it like this: x equals -3, comma, -5. You could write it out like this: x equals -5, comma, x equals -3. Or like the proper mathematician way to write it, you make your little squiggly brackets and you just put them inside. So -3, -5, kind of like that. Is the equation that we used in number 6 same or different to the one we used in number 7? They look different, but they're the exact same thing. I come up with my same solutions all 3 times, right? Just this one is in factored form. This is in standard form. So they're the same thing, they just look a little bit different. Okay, now we got to find x-intercepts in number 8. So what do I need to do first to find my x-intercepts in number 8? Yeah, I'm going to replace this with y. And then I want to set that equal to 0. So 0 equals x squared minus 3x minus 10. And then what do I do with this whole side?
You have to make it in factor form.
Yeah, we got to factor this. We need to come up with the 2 factors that would multiply together to give us this. So that means I look at my last number. What are my factors of 10? Perfect. Which one of those pairs is going to get me to 3? 2 and 5. How do I use 2 and 5 to get to -3? Perfect. -5 plus 2. So then that means my factors are going to be what? X minus 5, x plus 2. Okay, but now we're not done yet. Now we need to figure out what are the values of x that's going to make this true. So what do I need to plug in for x to make this part 0?
Positive 5,
Positive 5,
negative 2.
-2. So x equals 5, x equals negative 2. Okay? Clear? A little bit? Say clear as mud. Okay.
So is it really different when it says find the x-intercept and the value, what value of x?
Nope.
It's the same thing.
It's the exact same thing. Because when you say find the x-intercept, it's saying what's the value of x when y equals 0. So it's the exact same thing, right? Okay, I want to take a little more notes and just do a little more practice together on this paper at the front of the room. I don't think anybody turned it in last week, so if you don't have it in your bag, you'll have to come up and grab a new copy of it. But check your bag first and see if you have it.
You don't have it.
Okay.
So come up and grab it if you don't have it. Don't be throwing things.
Which one is it? This one? Oh. Yeah, I don't get it.
What is
This one up here.
Lucas, can you give me one too?
No.
Yeah, we're doing the 5-1 side, not the 427 side. See if you have it in your bag from last week, because we worked on it on Thursday. Okay. I don't want to do, let's say,
Are we not doing this one?
I'll explain that in just a second. Check and see. So we'll do practice together on this side for 15 minutes, 10 minutes, 10, 15 minutes of practice together, and then I'll give you the rest of class to do your assignment, which I'll tell you in just a minute, okay? So first thing, I don't think we need to go over this one again. I think that's okay. Put your phone away. Number 2, let's look at number 2. Put it all the way away. I don't even want to know that you have a phone.
You just call them and ask them.
Don't call people names. Number 2, let's look at number 2 together because this gets funny. What do you notice about number 2, about those 3 numbers?
They're funky.
They're all a factor of 12. That's good. What would the greatest common factor, though, be? 6, right? Greatest common factor is 6. So let's factor 6 out of this expression. If I take 6 out, what would be left over from this term? Try again.
6x squared.
Not 6x squared, 2x squared. What would be left over if I took 6 out of 6x? Yeah, 1x or just x. And what would be left over if I took 6 out of negative 6? Negative 1. Good. Okay? So that's GCF factoring. I factored this out. It's almost like I undid distribution, right? If I redistributed the 6 back out again, I'd end up with my original expression. But this is saying to factor completely. So now I need to take what's inside the parentheses and put it into 2 binomials. 2 binomials. Okay, so I need to come up with my 4 terms to put inside those 2 binomials.
Who created all this?
This has been like in existence since like 3000 BC.
Why did somebody just sit at a table and create this?
Because this all relates to parabolas. This kind of graph.
Oh.
This kind of graph. And that kind of graph relates to so many things in real life. Anytime like there's anything going up in the air, anything affected by gravity, it's a parabola shape. As well as like you use this in like business modeling. It's like the applications of parabolas are like vast.
Oh.
So that's why we're studying this, is because it's used when you're studying situations that can be modeled by a parabola. I didn't drop it. I threw it on purpose.
Stop throwing things. It's not what we do in class. We're here to learn.
I know I was using it as a demonstration. Okay. I can also re-demonstrate what behavior needs to look like. Just shh. Okay, so I don't even know what I was trying to say. Okay, my greatest common factor has to stay out in front. Okay, what definitely has to be my first times first to get me to 2x squared? Yeah, there's definitely got to be an x there. But what else has to be there? Huh? 2x, right? And what would be the number in front of this one? 1. Okay. And then what has to go here and here?
4.
How am I going to get to 1?
I don't know. I'm just throwing out stuff.
1 times 1, right? Just watch for right now, Aubrey, because you missed a few days last week. I'll explain it better in number 3, okay? This one's just like a little funny, right? 2 is only made up by 2 times 1. 1 is only made up by 1 times 1. So 2 and 1 have to be my first and first.
Yep.
1 and 1 have to be my last and last.
Yep.
Okay? But now I need to end up with my middle number when I combine my outers and my inners.
Mm-hmm.
What's my middle number?
I think so.
What's that invisible number in front of x?
1.
1. How am I going to get to 1 with 2 and 1?
2 minus 1.
2 minus 1. I need to make my 2 positive, and my 1 has to be negative. Okay? Let's do another one like that. Number 3. Does number 3 have a greatest common factor?
No.
Yeah, 1, but if I factored out a 1, would it change anything?
No.
No. If you want to, Karsten.
All day.
Okay, no greatest common factor. So we just need to convert this right into factored form. I need to come up with 1, 2, 3, 4 terms that go inside my 2 binomials, okay? What is going to be a part of my first times first? Yeah, x, because I need x times x to give me x squared. So x and x, okay? Well, 6 and 1, that's a possibility. I'm going to use my colors again. So I have to look at this first number, 6 times 1. What's another factor of 6? 2 and 3, okay? And let's make our little T chart over here. Okay, so my first times first has to definitely give me 6. What does my last times last have to give me? 49. What are the factors of 49? 7 and 7, 1 and 49. Okay, so now remember, I got to use like a combination. I have to pick one of these pairs and one of these pairs so that my first times first gives me 6. My last times last gives me 49. And then my outers and my inners give me negative 49.
7 and 7 and 6 and 7.
It's 6 and 1, but yes, let's try.
I would say 7.
I know I just messed it up. That's how they write ones in like most other countries, actually. Sometimes, but like in most people in like Europe or like other like Central America, even they write it like that.
This is off top.
I know. 6 and 1, and then you want to try 7 and 7. Look at that. What are my outers going to give me? What's 6 times 7?
A whole lot.
42. And what are my inners going to give me? What's 1 times 7? Can I use 42 and 7 to get to 49? What? How do I get to negative 49 though? Just subtract one of them? There it is, negative 42 minus 7.
Do I have to do the first equation first?
I'm not drawing.
What first equation first?
Like in number 2, we did like the 2x squared. Do I have to?
Yeah, but this one didn't have a GCF.
Oh.
This one didn't have a factor that I could factor out like I did in this one.
No, I thought we had to do that first and then find it.
No.
That's only if there's a greatest common factor.
Carson, put your hand back.
Okay.
Put your hand
Okay.
back on there.
Okay, so I figured it out. These four numbers are what's going to go in my little slots here, right? 6 and 1 are going to be my first and my first. And then 7 and 7. This one's easy because it's just the same number, so it doesn't matter where you put them, right? 7
What does X
and
what does
7.
F and X mean? Sorry.
F, first times first.
Oh, okay, yeah.
These are last times last. These are my outers. Those are my inners.
Preferably, I like to ignore those. Preferably.
That's fine.
I don't really follow that. I just kind of remember.
That's fine, right? Okay, and then I put minus because I needed them both to be negative.
I'm that John. I got us there.
How does
So if you refoil it back out,
You have to refoil them and then add it to that.
6 times 7 equal 49?
6 times 7, well, 6 times negative 7 is negative 42x. And then my inners, negative 7 times 1x gives me negative 7x, and that's negative 49x.
Oh.
Boom. You gotta add it. Shut up, Carson.
Mm-hmm.
But aren't you trying to find negative 49x?
Yeah, that was my outers and my inners. So look, first times first gives me 6x squared. Yeah? Outers give me negative 42x. Inners give me negative 7x. Those combine together to get to negative 49x. And then last times last would give me positive 49.
Okay.
So when you do this paper, you'll figure it out once you work through this. Okay. And I'll help you with this, and there's also videos on Google Classroom you can watch if you want to do it at home.
Okay.
See, that's mind blowing.
Does anybody? Yep. Does anyone have lead? Yeah. You do? I have. Is it?
We got to keep going. Okay, we're gonna move on. We're gonna skip number 4 for now. Move on to number 5. Because we have 4 minutes left until I need you to start working.
Word, teacher.
Okay. So number 5. What's the difference between number 5 and number 1?
What did you say?
Number 5 and number 1. What's the difference between, besides like the obvious? It equals 0. When you see that equals,
It is not factor.
when you see that equals, that should like tell you that you need to find the values of x. Values of x. What did you ask, Karsten?
No. How would that
No,
work?
that wouldn't
What
that
if your
wouldn't
thought
help.
process made you think that would work?
No, that won't work. What did you ask, Lucas?
Huh?
You asked something.
I didn't ask.
Okay.
I said it did not factor.
It does factor. It does factor. So we need to convert this side into factored form. Factored form. So I need to look at my last number. What are the factors of 4?
2, 1, and 4.
2 and 2, 1 and 4. Which of those pairs is going to get me to 5?
1 and 4.
1 and 4. I get to 5 with 1 and 4 by taking a positive 1 and a positive 4, right?
Yeah.
So what was my first times first going to be?
1 and 4.
Just x and x.
I'm wrong.
And then I've got x plus 1, x plus 4.
Minus 4. Oh, no, never mind. Sorry.
So what does x equal then? What does x need to equal? If this times this equals 0,
-1 and negative.
that's it.
You have to do the opposite of the ones in the parentheses. That's basically it. Yeah. You don't add them.
Right? You take x plus 1
Oh my God.
equal to 0. minus 1, x equals negative 1, and x plus 4 equals 0, minus 4, x equals negative 4.
How do you lend you one of his spreadsheets? How did you do my math?
That's right. Okay, let's skip to number 9.
We got 20 minutes.
You got 20 minutes to do your work. Yes.
I think you said after each problem we're going to do it ourselves.
Yes.
All right, so what are we going for?
I want to look at number 9. What's the difference between number 5 and number 9? Equals what? Instead of equals 0, right? So if you see something like this, your first step has to be making, that's not your first step. You have to get this side, the right side of the equal sign, to be 0. You have to totally clear out this side. So how am I going to make negative 4 0? Plus 4. Right? So what's negative 4 plus 4? That gives me 0. But if I added 4 to this side, I also have to add 4 to this side, right? So this left side becomes 3n squared minus 11n plus 8 equals 0. Now, I need to solve for x. I need to figure out the values of x that's going to make, or n, I should say, that's going to make this equal 0. So am I starting out in standard form or factored form?
Standard.
What do I need to do if I got to factor this out, okay? That means I need to come up with my 2 binomials that would multiply together to get me this. So what's definitely going to be a part of my first times first? N and n, right? Now we use our t-chart to come up with the other 4 numbers. So I look at my first term. What are my factors of 3? 1 and 3, right? And that's it, yeah? So I'm definitely going to use 1 and 3 in my first times first. And then for my last, what are my factors of 8? 2 and what? And 1 and 8. Good. Which one do you want to try and use? 8 and 1. Good. What's 1 times 8? And what's 3 times 1? Can I use 8 and 3 to get to 11?
Yes.
How do I use 8 and 3 to get to negative 11? Negative 8, negative 3, right? That does not mean I just put negative 8, negative 3 there.
Are you sure?
Positive. We got to use these 4 numbers from the little t-chart. So 1 and 3 are my first times first. And then 8 has to be my outer, so that goes there. And 1 has to be my inner, and they both need to end up negative, so it's minus, minus.
Told you, Rusty.
Okay.
Mr. Mars, you need to control cards. You need to be able to do it.
Okay, so these 2 factors multiplied together give us 0. We need to figure out what the value of n needs to be then.
8 equals 4.
No. So I'm going to take this first factor, just 1n minus 1, and I set it equal to 0. But let's rewrite this so it's not as weird looking. What's the same thing as 1n?
Just n.
N. So n minus 1 equals 0. So what does n have to equal? 1. Excuse me? And then I have also 3n minus 8 equals 0. How do I solve for n?
It's a plus
Plus 8. So 3n equals 8. How do I solve for n? Huh? This is first semester stuff. So n equals...
Oh my God.
n equals 8 thirds.
Right,
Don't stress.
I'm stressing because I don't know how to do this.
Well, you missed. I'll explain it to you. I'll explain it to you.
Don't even worry about it.
Don't listen to him. Okay. So now I'm going to give you the rest of class to work on your assignment and to answer questions to help you out. Let me explain to you what your assignment is. You have two options. I'm going to explain it to you. You be quiet.
I don't like that voice.
Stop interrupting me. Stop being annoying is what she's trying to get at.
Shut up.
Okay, you have two choices.
It's a great day to be alive again.
That's what I'm saying. It's great to be alive. That I can use. I don't think she's sharing chapstick with you.
You can put them on your finger and
Okay.
Just give me a-
That's more disgusting than sharing lips.
Not really.
not if you wash your hands. I wash my hands.
Who washes their hands?
Oh, you.
Okay,
Stinky finger.
you have two options. You can either do these 6 problems from your Wednesday paper. I'll hand back your Wednesday papers if you turn these in. Okay? These ones, this is harder, for sure. The easier version is just the back of this Monday
So
paper,
what's harder?
the Wednesday paper. So I'm just going to suggest, because I'm
Do you want us to challenge ourselves?
rushing, I want you to get it done.
I'm going to challenge myself.
I'm going to suggest everybody does the back of the Monday paper.
Word.
That's fine,
Keisha.
okay? Please don't call me Keisha.
Do it.
Okay. So the Monday paper is due in 15
So
minutes.
this one?
Yes, numbers 1 through 5.
I thought that's the front.
1 through 5.
Oh shit.
I make the rules, and that's the back. She
Yeah.
makes the rules.
Yeah. Shush. Shut up.
Numbers 1 through 5 are for you to do right now.
Come here, bitch. She called me a B-word.
I literally never said that word.
It's just you said bitch before. I got it on video.
What? What do you mean?
There's definitely a video using the
You guys shouldn't be talking. You should be working.
I got you there. Carson was meaner.
So when I put this back here, we would come up with my 2 binomials, right? And then these ones, it's easy. My first times first is just going to be x times x. So I get that x squared.
Yeah.
And then I just forget this last number. And I think about the factors. Right? And I know any of those factors, and multiply them together, I get to 12. But I need to pick them strategically so I can also get to this number. Right? Yeah. So if I can get to 1 using one of those pairs. Like using a good fraction.
It's not good for you guys.
So I would like
What's
12
that?
minus 1 minus 12 or 12 plus 1. Get me to 1. About 3 and 4 minus. That's the number there. So if I have a positive 4 and a negative 3.
Oh.
Right?
Yeah, that makes sense.
So my first times first gives me x squared. And then my outers give me negative 3x. My inners give me positive 4x, which combine together to get to positive x. And then my last times last gives me this negative 12.
Okay.
Does
So
that
you
make
just have
sense?
to find what numbers.
Yeah, so it's 2 numbers that multiply together to get the last number and add or subtract together to get the middle number. Okay? But then we also learned like the next level of complexity because now it's not just the last number, we also have the first number. And that's when it can get a little but we still are doing the exact same thing, coming up with 2 binomials that we multiply together to get a this, okay? So I have 4 little spaces to fill. And I know my first things first still has to have an x in it, okay? And now I got to figure out what number goes in front of the x, and also what numbers go here. So they have to be the same number. So I look at this first number, and what are the factors? Oh my god. And then what are my factors? I'm bringing in the So again, my first times first has to get me to 20. My last times last has to get me to 50. Okay?
I can't talk.
And this is kind of what I'm determining. Like, yeah, and the more practice you get with it, the better you'll be. I never had patterns.
Yeah. How do you guys say that?
Yeah.
I have last year.
She's not very good. But I was trying to look for characters. Yeah. Don't be concerned about them, be concerned about you, but know that if you're using photomath, you're just cheating yourself.
Shut the hell up, person.
I just picked two right now.
You're wasting your whole job.
Your jaw should not be moving at all. Okay, so 4 times 5 gives me 20.
Why are you laughing? This isn't a laughing matter.
Stop moving your jaw.
Can you help me?
Start moving your
Can you help me with your gun?
3 times 5 gives me this. Okay? So now I need to check. These are going to end up being my outer terms. These are going to end up being my inner terms. So what's 4 times 3? 12. And 5 times 5 is 13. Or 25. Or 25 and 12 is 13.
Yeah.
Yeah. So this is a negative 13, right?
Yeah.
So like a positive 12
Did anyone
minus
ask?
25.
Did anyone ask?
Okay, so I just found my numbers.
Which ones are inners again?
These are going to be your inners.
Okay.
And these are going to be your outers. Okay?
Okay.
So try filling it in.
Wait, outers are.
So you're minus 4. Yeah. Minus 4. And that's why I hammered it down like this is first, last, outer, inner, inner. Okay. So 4 and 5 have to be the first and first. That's usually what I start with. Okay, and then my last and last is 3 and 5. But I need to make sure that 4 and 3 are my outers. Where's that 3? And then 5 and 5 are my inners. Perfect. And then we gotta add plus or minus, So I think about it like I want my outers 4x times 3 to be a positive 12. So that means that 3 is positive.
Yeah.
And then my inners 5 times 5 has to be a negative 12.
Okay. Okay.
It's so right, and just remember, like I took a whole class just like this, and I'm expecting it to 5 minutes. So don't.
I'll just write down like my
Your
steps.
steps. Yeah.
Okay.
Yeah. Yeah.
Okay.
And if you wanted to start with this one and move on to that, I'm okay with that.
Okay.
You know what I mean? Yeah. Or not this.
Oh,
Or not that. Yes.
Okay. So also, can you help me with these real quick? Like I don't.
So factor form is just it's not anything with parentheses because this is in factor form.
This is the hours.
And then so remember factor form. I have them written down here. Factor form has like this in parentheses. Standard form is gonna have like x squared.
Okay.
And then that one.
That's neither.
This
is.
Yeah.
Okay.
Okay, you want to move this one with this?
And I only have to do this side of this paper, right?
Correct.
So that one.
Okay, so find all the solutions where this is going to equal 0. So how would I make x minus 15 equal 0? No. We need to look at just this part and just this part. Can I go to it first separately? What would I need to put in place of x in place of x to make this equal 0? No. What do I need to put in place of x to make this 0?
It's a whole lot of confusion.
So Okay, for some odd reason, you want to end up with $0 in your bank account, okay, at the end of the day. Okay, you get like an allowance for work or something, and they say, don't use it, you lose it. And they give you, and you want to spend $15. How much do you need to start with to end up with 0? Yes, that's it. That's all that's saying. So X is 15. That's how I make this part 0. How would I make this part 0? So that's positive 9. So then that was so smart than you. You're white. You're white. You're. That's really okay. You're putting this into factor. Yes. Yeah, and obviously C better than A. Yeah. The back of because I missed no, the way around. We find the factors of 16 and use that to get to 6. Okay.
Wait, when do we have to finish this one?
Today.
That one that's just notes. You don't
We
need to
don't
finish
need to
it.
finish this?
You don't need to finish it. This one that we worked on together, you do not need to finish it. It's not a grade.
What about the back?
It's just for notes. We did the back last Thursday.
Where?
Dude, I wasn't even.
But it was just notes.
so
It's just notes.
So
the whole paper, you don't have to do it?
So this is null and void. This does not count for a grade. You have to be specific.
This paper, front and back, is not for a grade. It was just notes. You can hold on to it though, so you could use it on your like test and to review and stuff. This is not a grade. What I am grading for today, hey,
Shut up.
what I am grading for today is this paper, 1 through 5.
Okay, so this one. Okay. All right, I got you.
Okay, yeah. Okay. This one, yeah. Okay, so we want to put this part into factor form. Factor. Oh, okay. And then once you get it in factor form, it's essentially doing this exact same thing. Okay? These two. Right, I'm saying this and this is asking the same thing. This, don't worry too much about this. I just couldn't see that one out of the
That's what you.
Okay, does that help you? Yeah. Okay. Thank you.
Has your first hour been better without me?
No, we miss you in there with this.
I miss
You're a
everybody
lot
in
more
there.
talkative in this class period than you were in first hour.
I know. I miss first hour more.
Well, can't have it both ways, huh?
I wish I could.
You just have 2 first periods and no fourth period.
Why did you switch out of the third anyway?
You brought it up on yourself. You brought it up.
I didn't bring it up.
You literally just brought it up. Just now you said you brought up my period.
Oh yeah. I mean, I said I miss first.
You guys have 3 minutes left. Better get something.
Oh,
It was wrong.
Wait, so
You
do
should
you
have it.
substitute this part with this?
Oh, wow. I'm my own business.
And they got me in the wrong.
Exactly.
And then.
Didn't do a thing.
And that's 5.
Literally, good chairs.
That was so easy.
So,
Oh yeah. How you
first,
doing?
like this one. Right?
Is that how you feel? Where the hell did Rusty go?
To the bathroom.
He's in the bathroom for like 20 minutes. You fucking throw it up in there? Bullshit. Gonna see your little girl side?
If you have any papers from last week, you can turn them back in. Or you can turn them in. You didn't turn it in last week.
I don't know. I just started
Do
one I had today.
you make this y too? 0?
Yeah, you can. Yeah. And then factors.
I don't know whether to be your friend or not.
Don't be his friend. I'll be his friend.
Quit writing.
Okay, I'm gonna send back some papers tomorrow. If you have anything from last week that you didn't turn in, You can turn it in today. And then this Monday paper needs to get turned in. That's all you got to turn in today. You need to calculator tonight. Get your Monday paper turned in. If you have any questions or you're freaking out about your grade, come and talk to me. You can come in during lunch. You can come in during tutoring. There are 2 more Friday schools left. Okay. But you just have to write the side and then this part, and then this part. What is that?
Smart.
Yeah.
Can I come in for tutoring tomorrow and do a little more on that?
Yes. I'm not going to be here tomorrow, but you can still do it. Or yes, I'll be here on Wednesday.
What if you didn't finish this side today?
Would you have time to work on it tonight?
Yeah, I'm gonna do all this.
Yeah, work on it as much as you can. Remember that there's videos in Google Classroom, and then if you have more questions, just ask.
Okay.
And I'm not like super tied to any due date for anything, just like the sooner the better.
Okay.
Okay.
Thank you.
Uh-huh.